Alrighty, starting off with 5.3. We're going to take a look at completing the square now to solve some quadratic equations. So there's different ways that you can solve quadratics. Last lesson we looked at factoring. Today we're going to look at completing the square. You want to make sure that if you're going to use completing the square, one of the first things is that make sure your a value is 1. We'll take a look at some examples where your a value is not 1, because it is still possible to solve by completing the square. But that's the first thing you want to do, is make sure a is equal to 1. We're going to move our x terms to one side of the equation, and when I say anything else on the other side, I'm talking about a constant value where you do not have a variable attached to it. This 1/2 b squared value, okay, we'll take a look at that. We're going to add that number to both sides of our equation, keeping it balanced as we work through it. Then what happens when you take and you add the 1/2 b squared value to each side, you end up coming up with a perfect square trinomial, and where you're going to end up being able to factor that. You're going to take a square root of both sides, and then you're going to solve for x. Okay, sound pretty simple? All right, let's get started. So taking a look at the first example here, what I want to do is I want to take my constant of -7, and I'm going to move it over to the other side of my equation by adding it to both sides. Now, because I know that I'm using completing the square, I am going to leave a blank to where I have to add my 1/2 b squared value. So the value that's going to go into these two places here, I'm going to take 1/2 of b and I'm going to square it. So my b value in this case is equal to 6. So we're going to take 1/2 of 6, which happens to be 3, and then we're going to square that, so it's going to be 9. So this is the value that I'm going to add to both sides. I'm going to add 9 here to both sides. The reason I'm adding it to both sides is, remember, you want to keep it balanced, so whatever you do to one side of the equation, you have to do to the other. You've created a perfect square trinomial here. This side, by using this process, this side of your equation will always factor. So this is just going to factor x plus 3 squared. And then 7 plus 9 is going to give us 16. So in the last unit, we talked about solving equations by taking the square root of both sides. So here's where that skill is going to come into play. We're going to take the square root of both sides. In the last unit, we focused more on squaring both sides. So by now, you should know that taking the square root and squaring something are inverse operations. So this just turns out to be x plus 3. Now, here's something you have to keep in mind. When you are solving and you take the square root of a number, your answer can be positive or it can be negative. So this is going to turn out to be plus or minus 4. And this is how I'm going to end up with my two solutions. So I could have x plus 3 be equal to positive 4, or I could have x plus 3 be equal to negative 4. Remember, we're finding the roots of our equation here, where it crosses the x-axis, or in some cases may not touch the x-axis. So I'm going to subtract 3 here, and I end up with a solution of 1. Subtracting 3 on the other side lands me a solution of -7. So I now have two solutions of x equals 1 and x equals -7. If you end up with nice integer values like that, a lot of times what will happen is you can go back and look and you can say, oh, you know what, I bet I probably could have factored that from the very beginning. And in this case, you could have. So this one could have been factored as a way of solving. So as you go through, there will come a point where I may say to you, what's the easiest way to solve this? Okay, and then you would have to kind of take a look at it and say, well, could I factor it? Could I complete the square? Or could I use the quadratic formula, which we'll get into next time. All right, let's take a look at number 2. If you'll notice, number 2 cannot be factored. So as hard as you may want to try, this cannot be factored. So not every quadratic expression or equation can be factored, and that would lead us to finding an alternate way to solving. So in this case, I'm going to subtract 5 from both sides. I'm going to set up for completing the square. So x squared minus 12x, remember I've got to add something to both sides. This is going to be equals -5 plus something. So looking for that 1/2 of b squared value. So my b value is negative 12. So I want to take hang on, I'm having technical difficulties with my pen here, guys. Okay, problem solved. B value, negative 12, divided by 2. And we're going to square it. So that turns out to be negative 6 squared. Watch your sign. That's a positive 36. So we're going to add 36 to both sides. So on the left-hand side of my equation, I have a perfect square trinomial. That factors x minus 6 squared. And on the right-hand side over here, I have 31. Remember, in order to undo a squared, I'm going to take the inverse operation, squaring it. So this becomes x minus 6 equals plus or minus. Now, 31 is not a perfect square, and it does not have any perfect square factors. So I'm going to leave it the square root of 31. Now, in order to solve for x, I'm going to add 6 to both sides. Now, in case you forgot, 6 and the square root of 31 are not like terms. You can't put them together. So this turns out to be 6 plus or minus the square root of 31. So in this case, we said right from the beginning that it couldn't be factored, and here's your solution. 6 plus or minus radical 31. And if you were to estimate that in your calculator and do a little bit of rounding, these are not nice integer value roots. Okay, these come out to be decimals in between your integers. So it's not something that you could have factored and found. So on the first day of this unit, we talked about the 3 different forms of a quadratic. We talked about standard form, we talked about intercept form, and we talked about vertex form. So our vertex form tells us our vertex value, and it also tells us whether our parabola is concave up or concave down. And on the first day, I also told you there was a way to go from standard form to vertex form algebraically. And that's what we're going to talk about in this portion. So there's some steps up there, and there's a couple different ways that you can do this. I know that if you had Miss McGee in 9th grade for Algebra 1, she did it one way, and I know that other teachers have done it another way. So I'm going to cover both ways in this first example, and then from there you can kind of figure out which way works best for you. So the first way that I'm going to do this is I am going to work on solely one side of my equation. So I have here y equals x squared plus 4x minus 6. And I want to put this into vertex form using completing the square. So what I'm going to do is I'm going to take this x squared plus 4x. I'm going to add something to it. Now, that same value that I add to it, I also am going to have to subtract. So these two values here are going to have to be the same. Now, just like in completing the square, I have to take half of my b value, and then I got to square it. So half of 4 is, good, 2. Now square 2. Good, 4. Now remember, I'm working on the same side of my equation. So the fact that I added 4 and then turned around and subtracted 4, technically I really didn't add anything to it. I just rewrote it. It still has the same value. But I can now factor the x squared plus 4x plus 4 because I just created a perfect square trinomial. So that's going to be x plus 2 squared. Now, over here, where I had the negative 6 that originally came from my original formula, and then I subtracted 4, I'm just going to combine like terms there. So that's going to give me a negative 10. So now, lo and behold, I have x plus 2 squared minus 10. Hey, look at that. I went from standard form to vertex form. That was a lot easier than finding the vertex like we did the first day, huh? So the vertex is negative 2. Thank you for remembering to change your sign. Negative 10. Now the y-intercept comes from your standard form. That you could have pulled right from the very original. That is just 0, negative 6. Okay? Now remember, when I first started this problem, I said there's 2 different ways you could do it. So the first way was we stayed on one side of the equation, and we worked on that. Now the other way is that you can do the completing the square like we did in the first 2 examples. So what I'm going to do is, this time I have y equals. So when I do the steps for completing the square, I'm going to do them just like I did in the problem above, but it's not equal to 0, it's equal to y. So I'm going to add 6 to both sides. Okay, last time I checked, y and 6 weren't like terms, so I can't combine them. So it's just going to stay y plus 6. And over here, I'm going to have x squared plus 4x. Now remember, I'm setting up for completing the square. So if I have to add something over here, I also have to add it over here. Half of b squared is 4. Now notice this time I'm working on opposite sides of my equation. So this time I'm adding 4 to both sides to keep it balanced. So over here on my left-hand side, I have y plus 10. Just combine the like terms there. And I'm going to factor this. This gives me x plus 2 squared. Now, you can leave it like that because that is technically an acceptable form of your vertex form. If you look on that yellow sheet that we did with the graphing that has the 3 forms on the front, that's one of the acceptable forms. Now the other thing that you can do is you can move this 10 over now that we're all done using it on the left hand side, and you can write it in the other vertex form that we had talked about. And if you'll notice, it looks exactly like the first way we did it. So it's going to depend on your personal preference, which way you like to do it. If you want to stay on one side of the equation and work, if you want to move that c value over, add the same value to both sides of your equation, and then move the value back at the end. Okay? Again, it's going to be a personal preference on which way works better for you. Okay, I'm going to give you guys a chance to check out 4 and 5 by yourselves, and then if you want to pause the video, try those two, and when you start back the video up, then your answers will pop up. But what I'm going to do now is I'm going to go ahead and skip to number 6. We're going to take a look at what happens when your a value is not equal to a positive 1. Okay, here's the answer to number 4. I kept everything on the same side of my equation. I like to work that way. But if you like moving it over to the other side, you still should have come up with the same answer. Okay, and here's the answer to number 5. Again, if you have any questions, make sure you star these and we'll go over them in class. Alright, so number 6, we're going to address the fact that what happens when our a value is not equal to a positive 1. And in this case, our a value is equal to a negative 1. So the first thing that this tells us is that this parabola is concave down. It opens down, meaning that if I graphed it, it would look like an upside down U shape. So the first thing that I want to do is I'm going to factor out that negative 1. So this is going to give me x squared plus 2x minus 3. Okay, so the first thing I did was I factored out that negative 1. Now I'm going to do my completing the square steps on just what's inside my parentheses here. So what I like to do is I kind of like to build a bracket, and then I have my room to work, and then I can go back and take care of the negative 1 at the end. So inside my bracket here, I'm going to do my completing the square steps. So I've got, let's see, half of 2 is 1. 1 squared is 1, so it's going to go there and there. So inside here, inside my brackets, I've got my perfect square trinomial, which factors x plus 2 squared. And then if I combine my like terms over here, I have minus 4. Now remember, this is all that I've done inside my brackets. But I also have that a value of a negative 1. You have to now distribute that negative 1 to the brackets in order to get an accurate vertex form. But remember, you want your a value to stay negative 1. So this negative, I'm going to keep out in front of my parentheses. Okay, notice I just distributed it to outside the parentheses there, but then this is going to be a positive 4. So my vertex is still negative 1, 4. And my y-intercept I could have grabbed way up from the beginning. That's just 0, 3. That standard form gives us the nice value of the y-intercept. Okay, so what I did was I factored out the negative 1 at the beginning, And then I worked inside the brackets here to find and did my completing the square, just like I did in the examples before. And then at the very end, I distributed the a value back into my answer. Okay, number 7, we have an a value of 2. So the first thing we're going to do is we're going to factor that out. Now, I know that you can't divide 2 nicely into 1, but we're going to work with that. And warning, warning, there's going to be a fraction, so brace yourselves. So we have 2, so this is going to be x squared minus 4x plus, wait for it, oh my god, it's a fraction. Okay, so I took out my GCF of 2, and I now have x squared minus 4x plus 1/2. It's alright, we're working with the fraction, you'll be okay, I promise. Okay, remember, I like to work inside my big brackets. So we have x squared minus 4x, I gotta add something. And I also gotta subtract that same value. So half of negative 4 is negative 2, but that squared is a positive 4, so we're gonna put 4 on both of those. This creates your perfect square trinomial. So we have x minus 2 squared, and then we have negative half minus 4. All right, I'll ease some of your fraction phobia. I'll use a decimal, so negative 3.5. All right, so now remember what I said in the problem before. You've got to distribute back your a value. So this is going to turn out looking like 2 times the quantity x minus 2 squared minus 7. So I distributed the 2 to this set of parentheses here with the squared, and then I also distributed it to the negative 3.5. So now my vertex is what? Good, thank you for remembering to change that sign to negative 7. And the y-intercept we could have grabbed right from the very beginning. That was 0, 1. All right, nice job. All right, let's go ahead and take a look at number 8. Yes, you have to factor out a 1/2. So because your a value is 1/2, you should have 1/2, and then you're going to have x squared. Now, when you're factoring out your 1/2 here, you want to make sure that you're careful about how you do it. Okay? So I'm telling you we're taking out the 1/2. Please be very careful as you go through and finish the rest of this problem. Okay, did you very carefully take out the 1/2? Keep in mind, you're dividing by 1/2. It's the same thing as multiplying by 2 when you take out that common factor. So that's the one thing that I really wanted you to be careful of. Okay, now go ahead and do your completing the square steps. Okay, how'd you do? Once you got that 1/2 carefully taken care of, it shouldn't have been too bad. Now your vertex is 5, negative 1/2. So again, remember I warned you, we're not always going to have vertex with integer values. Okay, so we have 5, negative 1/2. Your y-intercept you could have grabbed right from the very beginning, even though it doesn't say your y-intercept. You should have known that your y-intercept was 0, 12. So just some things that information you can grab along the way. All right, go ahead and take a look at number 9. Number 9 has a 3 for your a value, so we're going to have to factor out a 3. So very carefully take out that 3. Okay, so make sure that even though you're dividing 3 by 3 is 1, you still want to make sure that you add that 1 on the end there. All right, go ahead and do your completing the square process inside your brackets. Oh, look at that. We lost our k value. Okay, that plus 0 at the end there. So you should just have y equals 3 times the quantity x minus 1 squared. Now, if you added 0 at the end, I'm not going to take off for it. But when that value is 0, you're not going to see it written. But what it does tell you is that your vertex is 1, 0. So if you don't have a k value there, if your k is missing, you have to know that your k value is 0. Okay, that y part of your vertex is going to be equal to 0. All right, so there we are. So now algebraically we can go from standard form to vertex form. Again, if you had any questions along the way, I hope you starred your questions, and I'll give you a couple minutes in class to make sure that you are clear on how to go from standard form to vertex form by completing the square. All right, I'll see you in class.